as far as amplitude axis, something like that. Good. Okay. Lily, can you tell me something else, please? Axis is -3. Whoops. So I'm going to change my question. Yeah. I'm going to call it -2 instead of +2. Can somebody tell me why 2 wouldn't have worked? Well, if my axis is -3, yeah, Ben, go ahead.
Because it wouldn't get.
Yeah, if my axis is -3 and it goes up to 4, the highest value is only going to 1, right? So that's not going to work. Taylor, question, Taylor? Yeah, scrunch up, look on your face. That's what I'm asking. You can't read something, or?
No.
Okay, go ahead.
I don't know, just continue.
Okay, Taylor, what's the period for this graph? No. Forget about this right here. We're just dealing with this beginning equation here. We're just doing A here, okay? So we're just doing this. What's the multiplier in this case? So it's 360 divided by something, right? What are we dividing by in this case? Nope. Divided by 1. The reason it's going to be 1, Taylor, right? Because it's just cos theta. It's just 360. Action points.
Is the axis -3?
What's that?
Is the axis still -3?
Yeah, that's still -3. I'm just losing that. So my action points are going to be? The action points? Go ahead, Georgie. Good. Current phase shift is going to be? Somebody help me, what's the phase shift here? I mean on this one. This is no phase shift. And where does cos start at? Yeah, the question is why is that the case? Because it's not like cos theta or whatever, right? It's just cos theta. All right, Sarah, where does cosine start at, the axis or the max? Max. So I'm going to do a beautiful graph of this. If you don't want to do such a beautiful graph, that's fine. Okay, but my graph will be immaculate, as they all are.
Mr. Sadler,
Yes.
what's the point of the
What's that?
like? What's the point of the equaling?
Because we're actually going to do the algebra in a sec here. Okay. So I'm just doing the graph so you can see, and then we're going to use the algebra to confirm with the graph. Because when people are asking what are we actually solving here, I'm going to show on the graph, and then we're going to do it. Okay. So here's my graph coming like this. This will be the. I wonder if that's going to look like on the internet. You ready, guys? Stay in the game there. You graph this, please. Let's graph this. Okay, just a reminder for everyone, because you all will be forced to graph on Friday and on your final exam. What's the first thing I am going to put on my graph? Who am I up to, by the way? David, what's the first thing I have to graph here? The axis comes first. Okay. So I think I'm just going to count by ones today. Yeah, I don't know. Okay, so the axis is going to come across here at -3. Okay. All right, Julia, what comes next?
Put your max and min.
Max and min, which is going to be the amplitude, yeah. So what's the highest value of Julia going to be?
0.
Nope. 1, right? Because it's right, -3 and then you're going to up 4 to 1, so this is my maximum. Okay, since you've been here in 5 weeks, I'm still going to pick on you anyway. What's the lowest point on the graph going to be then?
-7.
Very good, -7. So if you're going up 4 to get to the top, you're going down 4 to get to the bottom. Okay. Great, excellent, wonderful. All right, Madison, what comes next, please? What's the third thing I'm going to do? Yeah, you can ask again.
Well, you gotta determine like your.
Yeah, so next I'm going to do just to get like the period rates. So do every point on the graph. This is going to be a scrunched up graph because I got to get all the way to 720 here. Okay, so I'm going to just count by 90 and hopefully I can get all the way to 720. Oh, no problem. Sure, I could have scrunched it out a little bit more. Okay, right? But that's me counting by 90 to get to 720. Right. Now, the reason I know I have to graph from 0 to 720 because it tells me right here when I'm solving. All right? If for you, you want to leave a little bit more space, feel free, but you're going to need at least, that's 8 entries, 8 squares to the right. Right. Okay, so next is going to be Brooke. Brooke, since you're leaving early today, what else do I do on this graph? Do you need anything else?
Like your points.
Yeah, I would do the phase shift would actually be next, but since there's no phase shift, we're just going to start right at 0. Okay, so where is my first point going to be on this graph, please? Brooke, where's the first point on the graph going to be?
One.
Good. And because it's a 0, so the first point's going to be here. Since there's no shift, you're still starting at 0 degrees, right? Because there's no shift, but it's going to be at the max. Caitlin, what's the next point going to be, please?
-3.
Yeah. Yeah. 9. We'll do X first, so 90 and -3, but yeah. Gabriella, what's the next point going to be, please?
180 and -7.
Yeah, and I'll fill in the rest. I hope you guys can get the pattern here from this. They might say, Mr. Sadler, why did you put me through that? The reason I did is because we're going to use this to help solve some algebra here for us, okay? And I don't want to have to do this a lot, but it's good to sort of see how the algebra lines up with the graphing, right? And there, oh, what a fabulous graph that is. Okay. Any question with the graph before we keep going here? I want the graph, not only this graph, but I want all the graphs you guys to knock out of the park on your final exam, right? I want that to be the ones you just say, okay, yeah, I got it. Exponential, inverse, reciprocal, I can do them all, right? No problem. But you'll have to do one like this for sure on Friday. All right, Logan. Picking on you now. Oh, not yet. I'm actually looking to solve when it's equal to -2. So what I'm actually trying to do in this case is I'm looking to solve this line right here. So from 0 to 720, I'm going to have 4 answers, it looks like to me. Okay, so there's going to be 4 actual things. It looks to me that I'm going to have 1 answer between 0 and 90. I don't have an accurate enough graph to say what that's going to be. I'm going to have another answer around 270. I don't know exactly where. Another answer between almost at 450. Another answer on the left side at 630. That's just from my rough graph. Okay, right? We'll get the calculator to find the exact values, okay? But there should be 4 answers of -2 between 0 and 720. So does everyone sort of see that? Logan, where that sort of makes sense, what we're doing here?
Sure.
You guys have had a 6-week off school. Okay, here we go. So let's get to part B, which is going to be -2 equals 4 cos theta minus 3. Logan, you're going to be up first. This is part B now. That was A. This is B. Okay, so Logan, try to brag on your behalf. You're the best at algebra in this class. Now you're not people don't want to beat you up, but you're the best at algebra in this class. Logan, what's the first step going to be to solving for theta here, please?
Turning a 3 over.
Very good. So that's going to turn into 1 equals 4 cos theta. All right. And then your second best at algebra in this class. What's the next step to solve for theta? Divide by 4. Okay, Riley, you're third best at solving equations in this class. What's the next step in solving for theta, please? What do we do? Cos inverse, okay? And you're the best at solving cosine equations in this class. Can you please solve for theta? $75.5, I'll call it 75.5. Okay, so let's look back to our graph here. To me, this looks like, what answer is this one going to be? Sorry? Yeah, this one's going to be definitely the left answer. I just did a rough graph, but you could sort of envision that being 75, okay? It's almost at 90, that's going to be this one. I'll mark that one off with the green because we're done with this guy. Okay, that guy's done with. All right? Okay, Callan. You can either keep working down the page this way or go to the right. Which one do you want to do? Okay, so how do you get the next angle going downwards? Yeah, 360 minus is going to go over this way, but that's okay. All right, so we're going to say here it's going to be theta is 360 minus 75.5. Just so I can line up like that, it's just easier to keep it balanced. All right, Madison, do you have a calculator, please? 360 minus 75.5. Try again. I think it's 2 something. How much? 284. Okay, 284.5. Now, going back to my graph, and this is why this graph is useful. Okay, what angle is that going to be on my graph? That looks to me like to be the second one, right? Okay, right? It's almost at, it's just after 270. This is only a rough sketch. It's still pretty accurate, okay? Just even on that rough sketch. Okay, so you sort of see how we're getting these here? Yeah, I'm just sort of confirming that those are the ones that we're done with. Yeah, Madison, go ahead.
Okay, I'm kind of confused about what order you're supposed to go in.
You can go in any order you want, okay?
So you just take that 75.5 degrees and you do like 360 plus.
Yeah.
360 minus.
Yeah. So we're going to, because basically you're going to get your 2 sets of angles in the first revolution, because basically what you found when you do your theta and your 360 minus theta, you find 2 angles in the first cycle. Okay, when you add 360, all you're doing is you're doing the same thing in the next cycle over here. Okay, that's all we're doing. Okay, so as you said, we're going to do the same thing. We're going to add 360 to this one, which is my period. And you get, oh boy, what was that, 435.5, I think. Someone with the calculator confirm that for me. Somebody pleased with the calculator confirm that for me? That's good. I thought it was, which that should hopefully turn into this one right here. Right? Because if you take a look, this is the same angle as that, just added to be 360. So go ahead.
So are we just, whatever answer we get for the first part,
Yeah.
you add 360 minus 360?
No, not always, not always. Because if you look over here, we did 180 minus because it was sine, right? Because we are using cos this time, whoops. Because we're using cos this time, it's 360 minus, right? Okay, so it just depends on what sort of how the
And
question
you do
goes.
a plus and a minus?
Yeah. All right, and again, it's not always 360. So in the next example, this isn't going to be 360. It's whatever the period happens to be. If we have a graph that's really close like this, okay, you wouldn't add 360 to get from here to here, right? You'd only add a lesser angle, right? So we'll get to that on the
You're
next
not
example.
using 360 just because it's cos?
No, it's because you're adding 360 downwards because it's the period in this graph. Okay, right? That's just over the shape that it
Oh,
repeats.
okay, so that side is because
Yeah,
it's
yes,
cos.
yeah.
That side is.
Yeah. Okay. All right, and then finally for the last one, we're going to add 360 again. What is that? 644.5, which hopefully should be this one right. On the final exam, there will be an honor quiz, so there will be a sheet of the final exam. We'll give it to you on Friday. Charles, that?
Why did you have 360 last time?
because if you take a look, the first angle here is, what is this, 284? Then it's just going to the same position on the next wave, right? Because the entire wave is going to be 360. So if you take a look, it's this side coming up, we get to get to the same part where's that coming up, you add 360, which is the period.
And there's sign you would.
It'd still be 360. It'd still be 360. This one would have been 180 minus here, but it would have been 360 plus here, always going down. Yeah.
So you only do the like 180 plus or 360, whatever, one time,
Yes.
and the rest you
Yes.
just add.
Yeah. Okay, let's move on to the next level of difficulty. I'm going to hit pause in the video, and then we'll move on to the next level of difficulty. I have 2 more examples today, I think. Now, I'm strongly going to recommend tonight, well, sort of in